In this video, I want to focus on the process of doing a U substitution. I don't want to focus on how to pick U. If you need to figure out how to pick U, look at the past video, look at this past assignment. But for this one, we're going to go over, okay, we figured out what U is. I'm going to basically tell you what U is, and then I'm going to go ahead and evaluate the integral. So it's more of the process here on how we're going to do this. So let's start with our U substitution. So I'm going to let U, we can't really do the antiderivative of this to the 10th power, because remember, like I said, it has to fit one of these formulas here. Now I can make it fit this x to the n formula if I do a quick little substitution. Let's just say that U is equal to 2x minus 5. So I'm going to now have the integral of u to the 10th power. And I can get rid of these parentheses because it's just u to the 10th power. Okay, what about dx? Because we can't do the integral of u just in respect to x. We're doing the antiderivative. We want it to be the antiderivative in respect to u, that we can actually integrate this. So what would du be? That would be the derivative of this. So du is going to be 2, and then the derivative of x, we're going to put dx. So the derivative of x is dx, and then derivative of 5 is 0, so that goes away. And let's solve for dx so we could substitute it in there. So solving for dx, we'll just divide the 2. And let me just put this in a different color so we can see that substitution as well. So this is for the dx part. So I divided the 2 to the other side, so then we're going to have du over 2. So really, what is that? That's just 1/2 du, isn't it? Just multiplying by half, really, if you think about that. So let me just simplify this a bit more by bringing that 1/2 out to the front. And then u to the 10 is going to be u to the 11 divided by 11. So you just do the antiderivative of u to the 10. That's really easy. We know how to do that. And don't forget we have that 1/2 out front. Let me give a little more room here. And then plus c. So that's going to be u to the 11 over 22 plus c. And u is 2x minus 5. So I just substituted that back in. And that's it. That's u substitution. So we turn it into a u, and we made it to where we can actually integrate it, to follow one of those formulas. Is that x to the n? And then once we found that antiderivative, plug that u back in, the 2x minus 5, and then we're done. Let's see. Let me see if there's another one. I mean, honestly, I should probably go through all of these. So this one, let me get it started for you at least. So this one, u is going to be sine of x. So then du is going to be cosine of x, if we're doing the derivative, times dx. Realize it's chain rule. Derivative of the outside, keep the same inside, then times the derivative of the inside, derivative of x is dx. Then to solve for dx, so I think I'm going to go through a lot of these, just, sine cubed, just showing you how to set it up, and then you'll have to do the integral. And then times, here's our dx is right here. And you'll see that cancels out with the cosine. You get u cubed over 4 plus c. I do want to point out real quick, when I do the u substitution, I did not take the integral yet. It's not until this step where I added 1 to the exponent, which I did incorrectly, that I added 1 to the exponent, that now I have done the antiderivative, and that's why I get rid of the integral sign, because now I have taken the antiderivative. Bring u back in. I told you I wasn't going to solve this all the way through, but I did anyways. You're welcome. Now I try to catch like each case. This is a typical trig case. Sometimes there's something inside there. Right here, you can see the inside function is 1 minus x squared, so that's going to be our u. So then du is 0 minus 2x times dx. Don't forget chain rule, bring down the 2. Just like the implicit differentiation, probably want to visit that if you forgot that. Let me just get rid of the 0. Divide the 2x to the other side. So it's du over 2x equals dx. Let's bring that in now. And then the 8 and the 2 cancel to give you 4. I'll bring that out to the front. The x's cancel. And then let's just write that to the 1/2 power. Over here, we'll make the inside function typically is going to be your exponent. With exponential functions, the inside function will be x to the 4th. Then dx, don't forget that part. And let's go ahead and substitute this in now. So we'll have x cubed e to the u times du over 4x cubed. The x cubes cancel out. That 4 is on the bottom. So I'll bring that 4 out to the front, but remember it's on the bottom. Then the antiderivative e to the u is just e to the u, so that one's pretty easy to complete. It makes sense. If you take the derivative of this, it should go back to what we started with. Oh, that's already to the right. Okay, I told you in the last video that we would go over how to do this. It's probably a lengthy video here by now, but I do want to go over each one of these cases because I know you're going to have questions on it later. Du is going to be 1 over x times dx. Remember, that's the derivative of natural log of x is 1 over x, and then chain rule. So here we multiply the x to the other side. It's actually one of my favorite types of antiderivatives is when we have this situation where the x ends up on top. We're so used to dividing by x to cancel an x on the top, but here it's the other way. We end up multiplying an x. So it's kind of cool how that works out. And you can see those x's cancel. And you're left with just the integral of u squared du. I'm sure you can figure that one out. And last one, this one's really probably one of the more difficult ones, and I don't even think I need to update this list. Let me see if it has it. No, it has it. Okay, that was a different list I was looking at. No, wait, never mind. This one doesn't have it. Actually, I think it's an issue here. I'm gonna look up. Yeah, that's what I thought. Kind of curious where that arcsine formula is coming from. So there we go. Just add one in there real quick. think I've seen this one before. Okay, so this one's going to kind of follow that arctangent one. Now, how am I going to make this work? I'm going to have to actually change things before I determine my u. And so remember that when you have something to the, like, x squared to the third equals x to the sixth, right? Because we multiply the exponents. So I'm going to do the same thing here at this e to the 2x. I'm going to make it e to the x squared. Why would I do that? I want it to fit that form that I'll show you right now. So if we make u to be e to the x, then du is going to be e to the x times dx, chain rule. So then dx, well, we divide the e to the x, right? So du over e to the x equals dx. So this will be the integral e to the x over 1 plus u squared times du over e to the x. E to the x's cancel out. We're left with the integral of 1 over 1 plus u squared du, which ends up giving us arctangent. Of u plus c, and just plug your u back in. Now I do want to point out something here. You're going to run into possibly two different things that this looks like. Now how do I know to use arctangent? It was because it was e to the 2x. I know I can split it up like this. Honestly, it just takes practice as you do more of these. So if I make this u, I knew it was all going to work out. However, if it was e to the x over 1 plus e to the x, and try this if you don't believe me, notice this doesn't have e to the 2x, and it wouldn't work out what I just did here on this one. You know, I couldn't make this being squared. But if I make u, this is actually a more common case. If I make u to be 1 plus e to the x, then du is going to be e to the x, because 0 to 1 is 0 times dx. So you end up with du over e to the x equals dx. So when you substitute on this one here, we would get integral e to the x over u times du over e to the x. E to the x is canceled, integral of 1 over u du, and that's going to be that natural log case, that 1 over u. So there is a little bit of a difference here between those two. So let me just put a little bit of space here. So do realize there's a difference with that squared. That's really what makes that difference. Because if we made u to be the entire bottom on this one, that e to the 2x, it's going to ruin it. That 2x is going to ruin it, and it's not going to work out to cancel the e to the x on the top. Here, it's just 1 plus e to the x, so the 1 goes away. We're left with e to the x, which will cancel the 1 on the top. That's why that works out fine. But fortunately here, we can get that arctangent to work.